AI Podcasts. I'm Ethan, and today we're unpacking an ACL 2025 paper titled KG Agent, an efficient autonomous agent framework for complex reasoning over knowledge graph. The short version is this. A small open model is trained to act as an autonomous agent that plans its own steps on a knowledge graph, calls the right tools, and knows when to stop. It reaches strong accuracy on Freebase and Wikidata benchmarks, transfers to a new domain, and runs noticeably faster than a well-known scripted baseline on a common test set.
Hey everyone, I'm Maya. Sounds promising? Who led the work?
The lead authors are Jinhao Jiang and Zhao, with collaborators from Renmin University of China and Boss Zhipin. The paper was presented at ACL 2025 in Vienna.
Great. So what problem are they tackling in plain words?
Large language models still struggle with questions that require multiple hops of reasoning across factual knowledge. Knowledge graphs hold the structure and the facts, but getting a model to use them efficiently is tricky. Earlier methods either stuff retrieve triples into a prompt or follow a fixed, handwritten interaction plan. Those plans can break as soon as a question needs an unexpected turn.
Right. Real questions rarely follow a script. How does KG Agent change that?
The authors combine three ideas. First, a unified toolbox of graph operations the model can call. Second, a running memory that records the question, what has been fetched, and the history of tool calls. Third, instruction tuning with code-like examples, so the model learns to plan one step at a time.
Walk me through the toolbox, quickly.
There are extraction tools to pull relations and entities, logic tools such as count, intersect, union, and an end tool that returns the final answer, and semantic helpers for things like relation retrieval and entity disambiguation. All tools share a consistent input and output format so the agent can chain them.
And the memory loop is what keeps the agent on track, right?
Exactly. At each turn, the model looks at the memory, selects the next tool with arguments, the executor runs it on the graph, and the memory updates. When it decides the answer set is ready, it calls end and stops. No fixed script.
Nice. How do they teach a small model to do all this without authoring thousands of programs by hand?
They synthesize training data from datasets that already include executable queries. From each example, they recover a reasoning chain, convert it into a short program of tool calls, and turn each step into a training pair. With about 10,000 such examples, they fine-tune a 7 billion parameter Llama model to act as the planner.
All right, let's talk evidence. Where do they test and what do they compare against?
They evaluate on Freebase-style datasets like WebQSP and complex web questions, the dev split of GrailQA, and on Wikidata with KQA Pro. They also check transfer to a movie knowledge graph with MetaQA. Baselines include subgraph retrieval methods, sequence-to-sequence models that generate Sparkle, and recent LLM tool use systems such as StructGPT, plus API models used zero-shot.
And results?
KG Agent leads on WebQSP and complex web questions, and also tops the GrailQA dev set overall, showing solid generalization. On KQA Pro, it is competitive across reasoning categories. For the out-of-domain case, they evaluate on graph-linkable subsets of natural questions, trivia QA, and web questions. Large API models remain strong on Wikipedia-heavy sets, but KG Agent is notably competitive when the task rewards reasoning over the graph rather than text memorization. On MetaQA, it adapts well with minimal examples.
You mentioned speed. How fast is it in practice?
On WebQSP, the reported average time per question is just under a second for KG Agent. StructGPT takes about 2.5 seconds on the same benchmark, so KG Agent is nearly 3 times faster in that head-to-head comparison, while staying in the same latency range as other local methods.
That's a meaningful difference. Any caveats we should be aware of?
A few. The experiments assume entity linking is available, which is common but a strong assumption. The out-of-domain evaluation focuses on questions that can be grounded to graph entities, which narrows the task compared to fully open domain settings. And although the agent keeps graph data on disk and streams what it needs, running at scale still requires careful engineering. The authors state that code and data will be released.
Got it. If someone wanted to build on this, what are sensible next steps?
First, bring entity linking into the loop and report true end-to-end performance. Second, extend the toolbox so the agent can move across graphs, tables, and databases without changing its core policy. Third, explore automatic discovery of new tools when the current set is not enough. And finally, test tougher generalization to unseen graphs and add good calibration so the agent can say when it is unsure.
That's a clear roadmap. Any closing thought?
In short, KG Agent offers a practical recipe for turning small open models into capable graph reasoners. With careful tool design, a simple memory loop, and program-shaped supervision, you can get strong accuracy and good speed without leaning on closed APIs.
Thanks for listening. This was AI Podcast.